Hello and welcome back. This lesson covers day 10 of Unit 7 on graphing rational functions. What is a rational function? A rational function is a fraction where the numerator and denominator are both polynomials. How do we find the X intercepts? The X intercepts are where the numerator is equal to 0. So we set the numerator to equal 0 and then we solve for x. Now, many rational functions have vertical asymptotes. These vertical asymptotes are vertical lines where the graph gets infinitely close to but never touches. So how do we find the vertical asymptotes? The vertical asymptotes are the values where the denominator is equal to 0. Now, many rational functions also have horizontal asymptotes. Now, a rational function has at most one horizontal asymptote. Now, a rational function would be in the form of f of x equals p of x divided by q of x, where both p and q are polynomials. So when the degree of p of x, that's the numerator, is less than the degree of q of x in the denominator, then the horizontal asymptote, abbreviated HA, is going to be y equals 0. And when the degree p of x, that's in the numerator, is equal to the degree of the denominator qx, then your horizontal asymptote, HA, will be the equation y equals a over b, where a and b are simply the leading coefficients of your numerator and denominator respectively. And finally, when the degree p of x, that's in the numerator, is greater than the degree of q of x, that's in the denominator, then your horizontal asymptote is, well, there is no horizontal asymptote in that case. If the degree of the numerator is 1 greater than the denominator, then there is a slant asymptote. All right, look at example 1 here. It says graph y equals x divided by x squared plus 1. So first we'll find the x intercepts. So to find the x intercepts, we set p of x, which is the expression in the numerator, we set that equal to 0. So the numerator is simply just x. So we say that x is 0. And if x is 0, then the whole fraction is going to be 0, which means y is going to be 0 as well. So your x-intercept is simply the point 0, 0. All right, next we'll find the vertical asymptotes, abbreviated VA. So to find the vertical asymptotes, we set the denominator, which is called q of x, equal to 0. So when we do that, we get x squared plus 1, that's the denominator, equal to 0. And then we can subtract 1 from both sides, and then take the square root. So we would get x is equal to plus or minus the square root of negative 1, which of course would then be plus or minus I, because I is the square root of negative 1. So that gives us imaginary solutions. And when we have imaginary solutions, that means that there are no real vertical asymptotes. So there are no vertical asymptotes for this graph. Okay, now we're going to find the horizontal asymptotes. That's determined by the degree. So first we notice that the degree of the numerator, which is first power or 1, is less than the degree of the denominator, because the denominator's degree is 2. So degree of the numerator, 1, is less than the degree of the denominator, 2. So when that happens, as we read above, your horizontal asymptote is just going to be y equals 0. Next, we'll use the table feature from our calculator to graph the function. When we use the table feature, we can get the points 1, 1/2, 2, 2/5, 3, 3/10, -1, -1/2, -2, -2/5, and -3, -3/10. Now let me show you how to use the table feature on your graphing calculator. So here we have the calculator on the right. What you'll do is you'll press the y equals button, and then you'll type in the equation on the top line. So I'm going to type in x divided by, and then you want a parentheses around the denominator. So I'll just draw that in. Okay, always have a parentheses around your denominator. So you have a parentheses, and then we'll type x squared plus 1, and then close the parentheses. All right, now you want to hit the table button over here on the right, and your table appears. And then you can scroll up and down to get the values that we want. Now, the reason why I chose these values in my table, that's positive 1, 2, 3, and negative 1, 2, 3, is because I wanted numbers that are close to 0. And I wanted some numbers on the right side of 0, which is positive 1, 2, 3, and some numbers to the left of 0, which is negative 1, 2, 3. All right, so you can see at positive 1, the value is a half, or 0.5. When x is 2, the value is 0.4, which is the same thing as 2/5. And when x is 3, the y value is 0.3, which is the same thing as 3/10. And so on, and the same for those negative x values. All right, now we're going to take the values that we have from the table along with the x-intercept, which is at 0, 0, and we're going to plot these points and draw the curve. And so here is the 0, 0. Here is 1 comma a half. This point right here is 2 comma 2/5. This point right here is 3 comma 3/10. And you have the same thing on the negative side. So this is what your graph looks like. You can see that the graph is approaching the x-axis, which is the horizontal asymptote of y equals 0. Y equals 0 is the same thing as the x-axis. So you want to make sure that the graph is getting infinitely close to the line y equals 0 on the right, and also to the left. All right, let's look at problem 1 here. We have y equals x squared divided by x squared minus 1. In step A, we want to find the x-intercepts. So we set the numerator, which is x squared, equal to 0. So if x squared is 0, then x is going to be 0, and that makes the entire fraction 0. So when x is 0, y is also 0. So your x-intercept is 0, 0. In step B, we want to find the vertical asymptotes, and that's taking the denominator, factoring it. So x squared minus 1 factored would be x plus 1 times x minus 1, and we set that equal to 0 and solve. So you get x is equal to negative 1 and x is equal to positive 1. So we're going to have two vertical asymptotes. In step C, we find the horizontal asymptote. We have to look at the degree of the numerator and the degree of the denominator. Since the degree of the numerator is 2 and the degree of the denominator is also 2, that means the degree of the numerator is equal to the degree of the denominator. In that case, the horizontal asymptote is the ratio of the leading coefficients. So the leading coefficients are 1 on the top and 1 on the bottom. So the horizontal asymptote is y equals 1 over 1, which is just 1. And then in step D, we fill in our table. Now we want to choose numbers that are around the x-intercept of 0, 0, but also around our two vertical asymptotes. So numbers that are close to the vertical asymptote of negative 1 would be negative 2. And a number close to positive 1 would be positive 2 on the right. But you'll also want to pick a couple of numbers that are in between the negative 1 and the positive 1, and also on the other side of 0. So we choose negative 0.5 and positive 0.5. Now let's pause and I'll show you how to figure out from the table how to get values that are decimals like negative 0.5 and positive 0.5. So here we are with our calculator. We want to type in the equation. So we'll press the y equals button and then start typing the equation on the top line. So we're typing x squared divided by, and remember you want the denominator in parentheses. So you'll start with an open parentheses and then type x squared minus 1 and close the parentheses. Now let's see what happens when we press the table button. When you press the table button, you see that you're getting values that are, well, in this case, we already have it set up to where the values are going to be going up by tenths. So like 1, then 1.1, 1.2. So that is one way to get your decimals. The way you set that up is by going into the table set feature. So you'd press the second button, followed by the table button, and then you see that the change in x is set at 0.1, and that's how you can get all of your decimals. The other way is you can set it to ask, and then you can type in whatever x value you want. All right, so let's go back to the table, and what are the values that we were looking for? We're looking for x equals negative 2. So we'll just scroll up until we see negative 2. And here in the table, when x is negative 2, y is 1.3 repeating, which is what we have here. We chose x equals negative 0.5. And there's negative 0.5 for x, and the y value is negative 0.3 repeating, which is what we have in the table. The next x value is 0.5, so we scroll down to 0.5. When x is 0.5, the y value is negative 0.3 repeating, which is what we have. And then when x is 2, you can scroll down to the 2. So when x is 2 in the table, the y value is 1.3 repeating, and that's what is reflected in our table. Now we have everything we need to draw our graph. We have our x-intercept at 0, 0, so we want to make sure we have a point at 0, 0. We have two vertical asymptotes, one passing through negative 1 and the other is passing through positive 1. So we're going to be drawing two vertical lines going through these two numbers. We have a horizontal asymptote of 1. So we're going to make sure that we draw a horizontal line going through y equals 1. And then we're going to make sure that all of these 4 points in the table are also in the graph over here. So when all is said and done, this is the vertical asymptote at negative 1. This is the vertical asymptote at positive 1. This line right here, this horizontal line, is the horizontal asymptote at y equals 1. This point here is negative 2, 1.3 repeating. This is positive 2, 1.3 repeating. This is your x-intercept at 0, 0. This is your point negative 0.5, negative 0.3 repeating. And this is positive 0.5, negative 0.3 repeating. Now, how do we draw these curves? Well, this curve over here, the red curve, has to pass through this point, and it has to be infinitely close to this vertical line and infinitely close to this horizontal line. So it has to be curved in this fashion. On the right side, we had to draw a curve passing through this point and also getting close to the vertical and also close to the horizontal. So again, it has to be curved in this fashion. And also in the middle, it had to pass through these 3 points up here, and it had to be infinitely close to this vertical line on the left and also to the vertical line on the right. So it had to be this kind of U-shaped or almost parabola shaped figure. All right, and all of this is the complete graph. All right, here's number 2. It's y equals x squared minus 3x minus 4, all divided by x minus 2. In step A, we're just simply factoring the numerator, so we get x minus 4 times x plus 1. In step B, we want to find the x-intercepts, and we do that by setting the numerator equal to 0. So for the x minus 4, we'll get 4, 0, and for the x plus 1, we'll get negative 1, 0. All right, in step C, we want to find the vertical asymptote. To find the vertical asymptote, we set the denominator to equal 0. So that's x minus 2 equals 0, and we get x is equal to 2. And then in step D, we find our horizontal asymptote. We do that by looking at the numerator and the denominator, the degrees. Well, the degree of the numerator is 2, and the degree of the denominator is 1. So the numerator's degree is greater than the denominator's degree. And in that case, we do not have a horizontal asymptote. All right, in step E, we want to find a slant asymptote. We actually do have a slant asymptote because the degree of the numerator, which is 2, is 1 more or 1 greater than the degree of the denominator. That's 1. So when the degree of the numerator is 1 greater than the denominator, then we have a slant asymptote. To find the slant asymptote, we simply divide the polynomial on top by the polynomial on the bottom. And we can do that by synthetic division. So since the denominator is x minus 2, we're going to have positive 2 on the outside with our half box. And the coefficients are 1, negative 3, negative 4. And then you just go through that process, bringing down the first term. 2 times 1 is 2. Minus 3 is negative 1. Times 2 is negative 2. Minus 4 is negative 6. So the negative 6 is your remainder part. And then you have 1 and negative 1, which is x minus 1. Y equals x minus 1 is the equation of your slant asymptote. And you'll see that drawn over here on the graph in just a minute or so. Step F is to fill in our table. Now we've got this negative 4 and 0 and 1 and 3 and 6. What you're trying to do is you're trying to find points that are in between your vertical asymptotes and your x-intercepts. So we have an x-intercept of negative 1, so we can choose something that's more negative, like negative 4. I just arbitrarily picked that. I could have picked negative 5 or negative 3, but I just arbitrarily picked negative 4. And then you'll see in the table that the y value is negative 4. I picked 0, and my y value is 2. I picked 1, and the y value is 6. I picked 3, and the y value is negative 4. And then I picked 6, and the y value is 3.5. All right, so we're just taking a calculator break here. So you see the original equation over here on the page, and you see how I typed it in. I was careful to put parentheses around the numerator and also to put parentheses around the denominator. So make sure you do that as well. All right, then let's press the table button. And now let's take a look at the numbers we chose on our page. All right, so we chose negative 4 and 0 and 1, 3, and 6. So you'll just scroll to those values So there's -4, -4. Here's 0, 2. Here's 1, 6. Here's 3, -4. And here's 6, 3.5. All right, we take the information from our table along with our two x-intercepts, our vertical asymptote, and the equation of the slant asymptote, and now we're ready to produce our graph. So let's see what the graph looks like. Okay, this slanted line that you see here is the graph, the line y equals x minus 1. It has a y-intercept of -1. It has a slope of +1. So there's your slant asymptote there. You should always draw your asymptotes with dashed lines. The vertical asymptote was x equals 2. So we have this vertical dashed line going through 2 on the x-axis. We have two x-intercepts at 4 and also at -1. So there's the one at 4. There's the one at -1. We have these additional points from the table. We have -4, -4, which is this point here. The next point is 0, 2, which is here. We have 1, 6, which is up here. We have 3, -4, which is here. We have 6, 3.5, which is here. Now we just simply draw a curve that's passing through those points, but also you want to make it so that it's getting close, really close to this vertical line here, but also close to the slanted asymptote here. Same thing with the other curve, passing through these 3 points, but also getting infinitely close to this vertical line, and also infinitely close to the slanted line. And this is your complete graph. And here's number 3. The equation is y equals x squared minus 4 divided by x plus 1. In step A, we factor the numerator into x plus 2 times x minus 2. That's difference of squares. In step B, we set the numerator to equal 0 so that we can find our x-intercepts. So from the x plus 2, we're going to get -2, 0. And from the x minus 2, we'll get +2, 0. In step C, we find the vertical asymptote by setting the denominator of x plus 1 to equal 0. So if x plus 1 is 0, we get x is equal to -1. So we have a vertical asymptote at -1. The horizontal asymptote, there's none, and that has to do with the degree of the numerator being greater than the degree of the denominator. So maybe there is a slant asymptote. That's step E. It is a slant asymptote because the numerator's degree is 1 greater than the degree of the denominator. So we find the slant asymptote by doing division, and we can do synthetic division. So with the denominator being x plus 1, we would put -1 on the outside, and these are our coefficients. Remember the placeholder of 0 to represent the missing x squared term. Drop the 1 down, and 1 times -1 is -1, plus the 0 is -1, times -1 is +1, and then -4 is -3. The -3 is your remainder, so you're going to ignore that, and then the other two coefficients represent x minus 1. So the equation y equals x minus 1 is going to be the equation of your slant asymptote. We can then go to step F, which is filling in our table. And again, I'm just arbitrarily picking points that are around these x-intercepts and also around the vertical asymptote here. So I'm just arbitrarily picking points that are somewhat close to this information here. All right, now we can finally go to the graph. That's step G. we just simply incorporate our two X intercepts. So this is negative 2, 0, and this is positive 2, 0. We draw in our vertical asymptote, which is x equals negative 1, and that is this vertical line here. Remember the slant asymptote, which is y equals x minus 1. This is that slanted line drawn there. Has the y-intercept at negative 1, and the slope is positive 1. All right, then these are your additional points from the table. Negative 4 is here. Negative 1.5 comma 3.5 is this point here. 0 comma negative 4 is this point. 3 comma 1.25 is this point. And 6 comma 4.57 is this point. When you draw the curve, make sure it passes through those points, but also draw it so that it's infinitely close to this vertical line here and infinitely close to the slanted line here. Same thing for the other curve, making sure it passes through these points, but also infinitely close to the slanted line and to this vertical line. And that is your graph. All right, and that completes the lesson on graphing rational functions.